So let me start the recording just in case somebody wants to view it afterwards. And yeah, so today pretty much what I want you to do is to study an online lecture, and the link to the lecture you can find in Microsoft Teams and in Telegram. And what we are going to be talking about today is how do we relate between functional programming and lambda calculus. Because as I mentioned, functional programming is heavily based on lambda calculus. And you have seen during labs that functional programming is a technique which allows you to write programs in the traditional way, well, more or less traditional way. But we need also to understand that behind the scenes, it is based on a very simple and beautiful mathematical idea. So the beauty of functional programming of lambda calculus is that everything is based on two operations. In lambda calculus, there are two operations called abstraction, is when you write a lambda expression, and application, when you apply something to an argument. And in fact, the whole program can be transformed into big lambda expression. And the execution of the program can be viewed as simplification of this expression. And it may be it's not obvious how can you do that, because when you do normal programming, you would define other functions. But on the other hand, probably it's quite clear that if you define the function somewhere, you can just replace this definition by lambda constructions of lambda calculus. And there are more tricky things, like what would you do with recursion, because recursive functions cannot be easily transformed. It's not clear how to transform recursive function into an expression. And that is exactly what this lecture will be talking about. How can we mathematically think about recursion, and how can we reduce all programs to those mathematical expressions. Also, there is one more step you can go towards beauty and simplicity, and there is a theory, mathematical theory, which is equivalent to lambda calculus, called combinatory logic, where you can leave just one operation, which is application, and reduce the program to the constructions of some very simple concepts called combinators. So it's also an interesting thing that everything, like all computational steps, can be defined just in terms of some combination of those combinators. So that is the topic the lecture is talking about. And so it's not like totally obvious lecture, so that's why you would probably take some time to study it. And also there is to see how you understand it. There is a quiz for you to do today during the lab time, and this quiz is it's in Microsoft Teams, so it contains a few like something like 7 questions, but some of them require you to do some programming, some not obvious programming, so to speak, and some understanding of lambda calculus. There is one question that you might not be able to do because it's pretty hard. Some of them are easier. So that's pretty much the plan for today. Let me ask you if there are any questions from the lab. I did not yet check the lab, but I will do it this week, and I will leave you comments, and probably we will discuss in more detail the lab assignment next week. And also, like the problems in the quiz, we will discuss next week and see how they can be done. The quiz, by the way, has the hard deadline, which is today at midnight. So yeah, you need to do it today, otherwise you will not be able to do it. It will just automatically close. Any questions? Anything like any problems you had during labs, everybody was able to check in the lab at GitHub, right? Hello, anyone there? Okay, I assume everything was clear.
Yes.
Good. Then I am not sure whether we need to do the like Q&A session today after you have the chance to see the lecture. Unfortunately, I am not available during the other time slot that we have because I'm speaking at the remotely at the conference, but I can do it after 3 o'clock. So if you think that we need a Q&A session for today, we can right now agree to have one, let's say at 3 o'clock, or yeah, let's say at 3 o'clock. Or if you think we don't need it and you can handle it using Telegram chat and questions, private questions, that would also be fine. Okay, so in this case, yeah, let's agree that if you have questions, ask them in Telegram chat. If I see that there are too many questions and something is not clear, then we will schedule the meeting ad hoc. Okay, so you have things to do, and if everything is clear, then just go ahead and have a good time learning some more functional concepts.
Thank you. Goodbye.
Bye.
Bye.
Bye.